Unified Diagnostic Services. We'll be discussing today on input output control by Identifier SID number 0x2F. As per UDS spec, the input output control by Identifier and the description is the client requests the control of an input or output specific to the server. So in order to understand what are the input and output of a server, I will take you through two examples of ECU block diagrams where we will be in a position to understand what are the inputs and outputs of an ECU. This slide shows that engine management system ECU block diagram. On the left hand side you see there are n number of sensor present. On the right hand side you see n number of actuators are present. Sensor are the key elements which produce uh, values which are essential to provide necessary control to the actuators, and it acts at a set point generators for the software which is running inside the control unit. So few key sensors in the engine management system like accelerator pedal position sensor, throttle valve position, air mass flow sensor, battery voltage, engine temperature, and crankshaft camshaft sensor, and as well as vehicle speed and CAN signals on the left hand side. These are sensor signal which we give as an input to the ECU control unit, and there are elements which is components are controlled by the ECU. Those are called as actuators, like ignition coil on a gasoline engine, throttle valve positioner, or fuel injectors or relays, and these are few things on the right hand side you see as an actuators. So the idea of this particular input output by control identifier you know SID is to substitute a value for the sensor or take a momentary control of the actuators directly from the tester by providing SID along with some parameter values. So these are helpful, in the garage diagnostic to identify some of the faults in some particular components, either both in the sensor side as well as on the actuator side. So this is the block diagram of engine ECU that we discussed. The next one is the ESP ECU. Similar to that, engine ECU on the left hand side you have four sensors, and the fifth one is control unit, and 6, 7 is again hydraulic modulator and wheel brakes, and 8 is engine management system and fuel injection. So why ESPS engine management system and fuel injection system? Because whenever there is a ESP intervention happens, then the engine ECU reduces or increases the torque. That depends on the electronic stability program controller request. So on the left hand side, from the sensor point of view, you see a R8 sensor with lateral acceleration sensor, and steering wheel sensor is the second sensor. Third is the brake pressure sensor, and fourth one is wheel speed sensor. So you have all four wheel speed sensors individually connected to ESP control unit. So these are the input unit, and the output side you have the brake actuators number 6. So these values can be substituted with the help of input output by control, output by control identifier SID, and momentarily we can take control of the or override the control of these values from the diagnostic tester, thereby creating some scenario to understand how the given or observed component is working. So this is where the input control by identifier service used by the client to substitute the value of input signal. That means either it could be an input signal directly which is coming from the sensor, you can change the value of it, or any sub function which is using this sensor signal, and there is some calculation happens internally. Even then, with the help of specific data identifiers, you can replace those values. That is also possible. So either you can directly change the input signal, overriding the input signal with a DID, or a internal server function can be also replaced with the external diagnostic tester DID values. So on the right hand side, these sensors are listed for just for your reference. In the next slide, this slide, the DIDs, again the data identifier, are used to force control to a valve or an output actuator of an electronic system. So anything like motors, solenoid valve, pumps, heaters, relays, all these comes under actuator, and these can be directly controlled by the diagnostic tester with the help of assigned DID for each of the element. With some specific parameter value, we should be in a position to override the function from the ECU server, and the diagnostic tester takes over the control of this component momentarily, and we call it a short-term adjustment. Now we'll get into the details of what do you mean by data identifier. Before going into the request response, understanding of this particular SID, there are few impact and calibration parameter which is happening inside the ECU need to be understood, because these are the data element which we are going to control from the diagnostic tester. So a data identifier is nothing but you can say a array of signal packed into a data packet with the unique data identifier values. So for example, you can view this as like an array, a one-dimensional array with n number of elements in it. So in this slide, I have defined identifier 0x0, which has 10 signals in it, and every signal has a unique value assigned to it. And these unique values are previously well defined within the control unit itself, so that when you give the reference value of 0C, it's always understood that is engine speed, and these are mapped internally in the software. So when you use a DID with the value 0C or 0D or 0.5, then it means that engine speed value, vehicle speed value, and engine temperature value, and so on. So like this, there are, you can have n number of data identifier defined inside the ECU. Why these data identifiers are required? So since the ECU has several inputs, and there are several calculated values which are created internally by the software, when the vehicle is going for a service, if there are some issue with specific circuit or with the specific components in the vehicle, then these data are read through a service called read data by identifier. In that service also, these DIDs are used to read the real-time values of the signals which are there as part of the ECU. So I'll repeat. So the data identifier is nothing but an array consists of n number of live signals present as part of each of these specific places. So we can have identifier 0x0 to 0x100. So you can have 100 number of identifiers, and inside each of the data identifier you can save n number of signal that depends on the calibration value what is available from the ECU software definition. So this is what is called as data identifier, and in this example the data identifier 0x00 consists of 10 signals. So I can define one more data identifier called 0x01, and I can have another 10 signals of different values variables. And I can also have 0x03, 04, 05 and so on. And I can group another 10 signal in each of the DID data identifier. Then I can have different number of signals present in each of these DIDs. And these DIDs can be called outside from a service called read data by identifier, where you can act, this can be act like a snapshot of values coming out of ECU. But in our specific data IO control, read data by IO control, our idea is to change, override this value with the help of our parameters in order to momentarily set and see what's happening by the consumers of these signals, thereby understanding the the software flow or the effect of execution in the software. So that is the whole idea of doing the short-term adjustments. And this is an example for actuators, previous DIDs, a group of signals together formed as a DID. Here the DID itself could be a single parameter PID, where you can see 4C is a throttle actuator, 69 is a commanded EGR, 74 turbocharger RPM, A5 is a command diesel exhaust fluid dosing. So these individual component value can be also set from the diagnostic tester and override these parameters in the ECU server. So this is also can be done with the short-term adjustment parameters. So there is one more thing we need to understand. There is one more parameter which is part of our request, is called as control option record. This control option parameter shall include all the information required by the server input signal, internal function and output signal. What does it mean? So this control option record gives four kind of possible parameters. One is I will go with the 0x03, the bottom. So we had in the previous slide for sensor value substitution, we had 10 records with the DID, and every element within the DID is having a specific value. So in order to change any of those values to some other value, you can always use the short-term adjustment parameter as part of your request. So the short-term adjustment with the previous slide where we saw DIDs, in each of the DID value you can uh, override the existing value with a new value with the help of 03 short-term adjustment parameter. So this is the first one I would like to discuss. So once this adjustment is done, then you want to tell the issue that I want to come out of this control and hand over the control to ECU. Then what you do is in the next request, you send this 0x00 return control to ECU. That means you've done a short-term adjustment and you are giving back to the control to ECU so that it brings back the default value or the current state values to those signals which are part of the DID. So this is called as return control to ECU parameter. And the next one also reset to default. This is also similar to return control to ECU, that it is requested to reset the input signal parameters referenced by the data identifier. So it's a default value. That means every signal has a current value and a default value, and you can ask the through the diagnostic tester for all of the DID signals, you can make the signals into their default values. That control is also possible. Even after this, you should once the control is set, then you should to come out of the result to default, then you have to again call the return to control to ECU with the new request. The other possible option here is the freeze current state. So with the help of this particular freeze current state, at any given point in moment, whatever the value is present as part of TID can be just frozen, and with the help of this particular parameter and read data by identifier service, you can read back all the values, or the positive feedback for the freeze current state itself will provide you all the parameter which is part of that DID. We will discuss detail all this in the coming slides. So there is one more parameter which should be sent as part of our request, is that controlled enable mask SID. So as we discussed previously, with the help of the previous short-term adjustment parameter, we should be in a position to change these values. Say for example, this is engine speed and this is vehicle speed. I'm changing values here and here. But sometime I don't want to change this engine speed. I want to change only this specific vehicle speed, like that. In that case, there is one more parameter called control enable mask record. This parameter is used along with the request, where it says that what are all the parameter which I want to change as part of the request. So that means wherever you see a value of 1% as a bit in individual position, then those relevant DID position signals are getting changed with the help of short-term adjustment. So this is true for a DID with array of signal in it. Otherwise, this is not required for an individual signal setting. That means either for actuator control with one single DID, it is not required, or a short-time adjustment for a specific variable or a signal or input sensor signal or some substitute function. If it is a single function that you want to change a value, then this control enable mask record is not required. This is only applicable when you have a DID with n number of signals as part of attached to it. Okay. So let us look at how does the input output control by identifier request is formed. So the SID value is 2F, and the data identifier is always 2 bytes. Okay. So as we discussed previously, data identifier could be array of signal packed into one DID value. That is also called as data identifier, or an individual component. Say for example, engine speed alone can be a data identifier, and these DIDs are previously listed when we develop the ECU. It was part of your software development. So this could be a calibration parameter with the master list, or it could be a hard-coded values which are available from the beginning of the project. So DID, again reiterating that DID could be array of values or could be a single value. And the control option record, as we discussed previously, it has four possible options of control option record. Uh, the one is doing a short-term adjustment, and second thing is requesting to a default state. Third thing is requesting the freeze frame for the given parameters, and the fourth one is releasing the resetting the control back to the ECU with the current status being reported back. So this is four option. Along with that, we must understand one thing. Only for the short-term adjustment alone, we need to send the values for each of the position of the signals and its value through this control state 1 to M or 1 to 10 in our case for 00 identifier. So yeah, so this is where the values should be sent from the diagnostic tester to the ECU. And for what are the places within that array is valid, then that can be mentioned through this control enable mask record ID. So this is a ID where you can enable each of the signal or disable the signal. And this is the response, positive response message which you get for input output control by identifier request. So as we all discussed previously in the previous sessions, so 0x2f becomes 0x6f with addition of hexadecimal 40 to the response. So this is a positive response, and it gives with the data identifier, 2-byte data identifier. In our case, it could be 0x00, something like that. And the control status record, that is nothing but we have a value of short-term adjustment. If it is the case, it's 0x03. And it will also give all the signals which are part of the data identifier, if it is array of data within the identifier, or it's a single value if it is a single signal being set from the diagnostic tester. So the C1 parameter, which is nothing but the control status record, control state parameter, is depends on whether it's array of DID signals or it's a single signal which is set from the diagnostic tester. So the negative response in this case is the request incorrect message length or invalid format with a response code of 7F followed by this NRC negative response code, or 0x22 condition not correct, and 0x31 is request out of range. So there could be n number of reasons for it. One thing is the requested identifier value is not supported by the device. So for example, we might have defined DIDs from 0x00 to 0x10, but we are trying to send 0x11, then the DID itself is not present as part of the ECU software, then it says that this is not supported by the ECU. Then the other possibility is the value contained in the parameter which is to control a particular actuator is not correct. So for example, we are controlling a solenoid valve which has a percentage of 0 to 100 percentage. If you are sending a value greater than 100 or less than 0, then the requested value is out of range, then it sends a NRC. And the third thing is, if we have a data identifier of 00 with n number of signals as part of it, and if few signals are out of range or within the acceptable limit, then also it sends a request out of range NRC. And the last one in this case is we have this control enable mask record against each of the data identifier. And if the control enable mask identifier record that if provides an invalid setup for the DID, then also the request out of range is given back. And the last NRC code here is 0x33, and here the security access is denied for some reason. So this is the flow of response or flow of messages from ECU tester to ECU. So initially we start with service ID 0x2F. The key one respond, the key one is it a minimum length check? That means you should have one service identifier, one data identifier, and one input output control parameter. That means service identifier is 2F. DID could be some 0x00 or something like that, and input output control parameter is like short term adjustment like that. So then if condition is true, then it moves to yes, then it supports the 2F service, and also it checks the input output parameter is supported. Then the second key is the IOP is short term adjustment. That means it includes 1 byte service identifier and 2 byte DIT and 1 byte input output control parameter. And followed by that, it will also have nth byte control state, nth byte, and control mask if applicable. As previously we discussed, the n number of signals and its mask also sent as part of the request. If that length is also true, then it goes to the control state supported until control mask is supported. Then if the security is also supported, then finally you get the positive response. On the right hand side, you also see two columns. There are few optional, checks also possible. If there are some vehicle manufacturer specific or ECU supplier specific codes are then, and they can be also given back. But otherwise, this is the flow of, messages or the requests going through the tester and the ECU and the responses. Thereby, we understand the flow of request with the help of this diagram. Okay, and now here is an example for us to understand how this input output control identifier is happening. So we have taken an example of an actuator, and the actuator name is air inlet door positioning. And the method in which we are going to control this is short-term adjustment parameter. So what we do is the DID for this air inlet door position is 0x9B00 air inlet door position. That is the data identifier 0x90 9B00. Sorry. And the adjustment value should be given in terms of percentage of value varies from 0 to 100. Okay. So our testers start with the request 0x2f followed by the data identifier, that is 9B00, as you see here, and followed by the 03 and 3C. 03 is short term adjustment parameter, and 3C is the percentage of value which we are expecting the air inlet door position actuator to response. If I am right, 3C correspond to some 60 percentage of actuation. And the HVAC ECU responds with a positive response, that 2F has become 6F, that is a positive response, and the DID value is the next byte, and followed by we have 0x00, that is nothing but the short term adjustment value, and followed by 0x03, and this is the parameter which we asked for short term adjustment. Oh, sorry. So 0x9b and 0x00 is the data identifier bytes, and 0x03 is the short-term adjustment parameter, followed by 0x3c is the positive response for 60% of opening of this particular inlet door open position. Here you please see that we have not used any mask identifier, mask record here, because it's a single one component, so we don't need to really do any kind of mask record is required. But if 0x9b00 is identifier where n number of signals are present, then here we should be sending the data mask record also as part of the request, and the response will also be not one signal, it will be n number of signals, depends on the data identifier what is been defined. So the first step what we have done is, previously we set the ECU to a specific opening of the particular the air inlet door position. So once the control is given to the tester by the ECU, then the tester, in order to close the operation, the tester should give back the return of the control to the ECU. That's where the specific step is coming into place. So once the adjustment is done, then you should send one more request to the server with this sequence of 0x2f, and 9b00 is the DID data identifier, and, this is the control parameter to set back to return control to ECU. So by providing this, the positive response 0x6f, 9b00, and 3a. 3a is the current state of idle air inlet door position percentage. I think this is approximately 58 percentage or so. So by looking at this, what the sequence is like, the first you should set the value, and you should also release the that particular DID with the help of return control to. Yeah, I think we have come to a conclusion of the current session, and our next session will be on the Security Access Service 0x27. I hope the information is useful for you and your time is well invested. Thank you and see you again. Bye.